This question is from NEST 2023 second shift. A beam of monochromatic light is incident on one face of a prism of angle 75 degrees. If the angle of incidence is 60 degrees and the refractive index of the prism is √3, then the correct option about the emergence of the beam from the opposite face is no emergence, grazing emergence, emergence with an angle of 60 degrees from the normal, emergence with an angle of 30 degrees from the normal. Monochromatic refers to light of single wavelength. The angle of prism is 75 degrees. Let's draw the figure first. Suppose this is our prism. This angle is 75 degrees. Now usually we show the incidence on the left face, right? So suppose this is the normal. And let us suppose this is the normal on the other side. Okay. Now let us consider this as our incident ray. This as our incident ray. So this is our angle of incidence I 60 degrees. Right. Now because it is traveling to an optically denser medium, it is going to bend towards the normal. So let me show it in green color. Don't think that it will change its color. Okay. This will be the refracted ray. Okay. So let us call this angle of refraction as R1. And then let us call the angle of incidence on the other face of the normal, on the other face of the prism. Let that be R2. And then let it emerge like this. So this will be the angle of emergence, and this is what we need to find. Okay. Whether it is whether the ray can emerge, and if it can emerge, what will be the angle of emergence. Okay. All right. Simple question on Snell's law. Let's apply the law. Okay, Snell's law. Sin I upon sin R, that will be √3. Okay, that will be √3. And then if we apply it on the other face, okay, if I apply it on the other face, then what would it be? Sin of R2, okay, sin of R2 upon sin of E will be 1 upon √3. Okay, sin 60 upon sin R1 √3 for this face, sin R2 upon sin of E on the other face. Now, is it possible to obtain a relationship between R1, R2 and 75 degrees? The answer is yes. Look, if you consider this quadrilateral, okay, if you consider this quadrilateral, okay, the one which is formed by the two normals and the two faces of the prism. Okay, so in that quadrilateral, because these two angles are right angles, right? Because these two angles are right angles, 75 degrees plus this angle, okay, let us call it alpha, 75 degrees plus alpha, that is 180 degrees, correct? But in the triangle formed by the two normals and the ray inside the prism, the sum of the angles R1 plus R2 and angle alpha, that will also be 180 degrees. Clear? R1 plus R2 plus alpha, that will also be 180 degrees. R1 plus R2 plus alpha. Okay. Now, if that relation holds, then we can say that R1 plus R2 is 75 degrees. Correct? R1 plus R2 is equal to 75 degrees. Now we have these relations. Let us start with the first. Sin 60 is √3 by 2. Okay. Sin 60 is √3 by 2. Sin R1 we don't know, but we will now find it. So √3. √3 goes. Sin R1 will be how much? 1 by 2. Therefore, R1 will be 30 degrees. Okay, R1 will be 30 degrees. Now, use third relation. Okay, use third relation. If R1 is 30 degrees, how much will R2 be? 75 degrees minus 30. So R2 will be 45 degrees. Now go to second relation. Okay, go to second relation from 2. Sine of R2 1 by root 2 upon sine of angle of emergence is equal to 1 upon root 3. So what is sine of the angle of emergence? Sine E is equal to root of 3 by 2. Now because 3 by 2 is greater than 1, root 3 by 2 will also be greater than 1. But sine of E can never be greater than 1. So is such an angle possible with the given prism and angle of incidence 60 degrees? No, it's not possible. Correct? It's not possible. Therefore, no E exists. So the ray will undergo total internal reflection. But as far as the question is concerned, the correct option is A, no emergence. Okay? No emergence. Have you understood the question? It's a pretty simple question, okay? Most of the ray optics questions can be solved using Snell's law, but depends, okay? Especially the prism ones. Okay? So no emergence. What does grazing emergence mean? Grazing emergence means the angle just grazes like this. Okay? You know that angle of refraction when it is 90 degrees, it is known as grazing emergence. Okay? And that's where you get the critical angle situation, right? So can you tell me the critical angle of incidence for the prism? You can take it as homework, or let's do it now. Okay, what will be the critical angle of prism? Can you find it? Look, if we want the critical angle of incidence for the prism, okay, we want the angle of refraction to be 90 degrees, grazing emergence, refractive index 1 upon root 3. So what will be the critical angle? It will be sine inverse of 1 upon root 3. Let's find it out quickly. Okay, let's change it to degrees. Sine inverse of 1 upon root 3. That's 35.26. Okay, that is 35.26. And look, what angle have we got as our angle of incidence? I think it is 45 degrees. Yes, R2 is 45 degrees, and because 45 degrees is greater than this angle, it will not come out. Okay, you can also argue that way. Okay, so that question is done. I hope you understood how we found out the critical angle.